Yeah, so it's that. So tonight, young Peter here is going to take the show and explain what we're going to do. What he's doing, we will be able to do in the shack if people want to do in the future, and a few other electrical things. Right, Peter, it's all yours. Have fun.
Right. Sorry, there's quite a few things going on tonight. We're live streaming probably for the first time ever onto YouTube. So just so that one of our members can watch it, but also hopefully to set a bit of a precedent. Because it'd be nice to sort of have a go at either live streaming or recordings of these talks in the future. I am hugely well organised, as you can tell, so I'm just going to find my PowerPoint. Google Drive, and then we'll get going. Right.
There you go. I'll shut you up.
It's working. Okay.
Yeah, I've got a bit of a delay. We'll put you off eventually.
Yeah. Okay. There we are. Okay. Brilliant. Okay. Right, welcome everyone. I'm Peter, M0SWN. I'm sure most of you know me, but there's a couple of new faces here tonight. Tonight we're going to be doing a bit of a workshop kind of thing. But first I'm going to start with a very, very short talk that I threw together this morning. So, tonight's not specifically about SDRs, but more about these SDRs. They're called Realtek dongles or RTLSDRs. And they're very cheap, and hopefully we should learn a thing or two about them today. So in this quick PowerPoint, I want to talk a bit about the history of these dongles, a little bit about how they work to the best of my understanding, go through some of the uses of the dongle, and then a little bit of a discussion about how SDR fits into amateur radio going into the future. So, okay. These aren't designed for amateur radio, they never were. These are digital TV / FM radio / digital radio dongles. You put them into your laptop, you plug in this somewhat okay antenna into this, and in theory you can pick up digital TV or FM radio using someone's software, the company's software. These have been mass produced at a very, very high volume, and it's got the cost down a lot. You can easily get these for £10. If you look at the right place, you get it for £6. If you bought 1,000 of them from China, you could probably get them even less than that. Okay. Some very clever people, a guy called Antti and a guy called Eric and a few other people figured out from experimenting with this that you could sort of intercept part of the chain, the software chain this used to pick up radio. So they managed to find a way to dump the entire IQ. IQ is basically like a digital version of the RF spectrum that it samples. And by doing that, you turn a TV dongle into a wideband scanner, effectively, with a bandwidth of about 2.5 megahertz, covering a frequency range from about 20 megahertz all the way up to 1.3 gigahertz. So something which starts off as being a very cheap but sort of single-purpose device is now turned into an absolutely fantastic piece of equipment that normally would have cost you thousands of pounds before something like this came along. There are some amateur radio sort of alternatives that have spawned from this, which obviously do the same job a lot better, but something similarly spec to this, designed specifically for amateur radio, looking more like 150, 200 pounds, things like the SDR Play or the AirSpy dongles. They're not the same, they're not the same device, but they're comparable in their features. So this is an extremely low cost way to get into SDR. So how does it work? That's what this looks like if you take the black plastic off. There's not a huge amount of stuff on this really. You've got your stupid connector, the microcoax connector, which doesn't fit anything. So it's all about adapters with these things, as I'm sure you'll find out. That there is the Realtek chip. It's a 2832U, and that's what takes your RF and samples it from an analog to digital. So it's an ADC, and that's really what does the magic. That's what makes this so good as a scanner of what it does. It's also got a local oscillator on it and some sort of band pass filter so that the ADC doesn't get overloaded. This is a block diagram that tells you how this generates your IQ from the RF. I'm not an expert on this matter, but I did read a few articles on Google, so I might be qualified to explain how this works. Basically, RF comes in there through the silly connector. You have your bandpass filter that limits the amount of data that the ADC has to deal with. Too much data and the ADC won't be able to do its job at all. So that's where your limit of about 2.5 megahertz bandwidth comes from. You then have these two here. These are effectively mixers. Just notice this. So they're called, it's like a quadrature mixer or something. Not sure about that. And they effectively mix the RF with the local oscillator twice at 90 degrees phase difference. These then go through filters, and then they're combined back together in the ADC to create your IQ. Think of IQ like the audio version of RF, except instead of it being analog, it's digital. So it's almost like if you wanted to have a computer write down in ones and zeros a certain chunk of the RF spectrum, that's what this circuit does, and that's extremely powerful. Because you can take that IQ, you can log it into a file, and then you can play back that file. So I saw an example where someone had a really busy pile-up on 20 meters, I think it was, and they recorded the whole thing on an SDR, and then you can load it back up on the computer, and you can just click on the QSO, and you can listen to every single QSO within this band. All, you can listen to them all over and over again, just from this effectively quite small file. And that's the magic of IQ and the magic of software-defined radio makes that work. So what can you use it for? Here's some of the uses.
Can't see that.
That's okay. That's some of the uses that I can find online for this dongle. Because it covers such a wide frequency band, but more importantly, because it doesn't have any hardware limitations. It doesn't just do what it's made to do. This is more like, it gives you the option to do whatever you can write software for. So the other day I was decoding some D-star with this, just as a little test. That's one example. You can listen to anything. You can listen to anything that's on between those frequencies that you can demodulate that isn't encrypted. So things like Coast Guard, PMR radios, amateur radios, VHF, UHF, some of the higher HF bands. Aircraft, you can track aircraft, we should do a demonstration of that later, because aircraft all have, well, lots of them have transponders on them, so we can use that to track where they are, which is always good fun. Ships, same deal, they have AIS transponders on them. You can use it to, as it was designed to, listen to radio, listen to FM radio and digital radio, amateur TV was something I was reading about earlier. Actually no, that wasn't, that was confusing two different technologies there. But you can use it as a sort of spectrum analyzer as well. So I've played around with a few things like 433 meg, used by loads and loads of things because it's free, it's license free. So if you have a wireless doorbell, you can plug your RTLSDR into a computer and you can see the signal coming off this wireless doorbell. in theory, if it's using something like FSK or something, you could reverse engineer the protocol, you could get a transmitter, and you could fake that wireless doorbell, and then you could sit outside someone's house and you could...
Is that the modern version of lockout chickens, is it?
Yeah.
In theory, you could find vulnerabilities with like garage door openers and gate openers. Lots of stuff like that's been done before. Yeah.
Garage door openers are a bit of a problem. They have a rolling code.
So it's not going to work on everything, obviously, because that would be.
Doors on the street.
But it's really useful as a piece of test equipment and as an experimentation device. If you ever just think you've got this thing and it's transmitting over 43 meg or something like that, you can find where it's transmitting, you can see the transmission, and that can be a really useful piece of test gear. Right, I'm starting to get all of my own voice. What else have I got on my list? High altitude balloons, perfect for receiving signals off high altitude balloons. You can use it on Android, you can use it on tablets, you can use it on smartphones, no iOS, sorry, only Android. Satellite work, things like space station, that transmits a AX25 packet repeater. It's a bit like a message board over radio. You can listen to that with this, even I think just with the stock antenna that comes with it. If there's a good pass, you'll pick it up. And then, as I said, hardware development, spectrum analyzer. Okay, I'll do a few more demonstrations after this PowerPoint. But recently, and only very recently, we started seeing radios that look like this. Or sometimes they are completely normal radios, but they have a so-called PAN adapter on them. They're still using the standard analog radio technology, but they also have a little screen on them, and it shows you the spectrum. Those are alright, but it's effectively the same as having this running on a laptop next to a radio. Some newer rigs, like the 7300, is an SDR radio, so it doesn't use all of the analog circuitry. It's working similar to how this works, with an IQ, which is really good because you can get your visual display of the spectrum, and you can click on multiple QSOs, and you can I think you can have more than one VFO, and you can listen on one and transmit on the other. It's an emerging technology, and I think it's going to become bigger and bigger and bigger. Certainly within the last few years, we've gone from a couple of these to every new radio being released having either a PAN adapter on the side or being a full SDR radio. We also get stuff at the bottom, like this is a Flex 6700. That is a proper SDR. So it's built from the ground up for amateur radio and for industry as an SDR transceiver. Doesn't have a screen on it. You plug it into your computer or you plug it into a network, and you run Flex's software. So instead of having your radio with the knobs on it and the screen on it, you have a piece of software and you control the radio from your computer. To complicate things, they also released a piece of hardware that does that all for you, so that you can pretend you still have an old-fashioned radio even though you don't. And I had to go on one of those at the National Radio Centre. They've just got a new one. It was alright. Until it crashed, but it was alright. So yeah, mixed feelings about that, but I do like the SDRs. I like the way things are going. Simply just because there's so much more you can do with it, with software updates, new modes, digital modes. There's a huge amount of potential, and new ways of using these dongles. They're coming online every week. Just look at the website, the RTL website, RTLSDR.com, and it's a forum sort of thing. And there's every day there'll be posts on there, and someone has done this with this, or they've set up something else with it. So it's a brilliant piece of kit, and it's being developed all the time. So let's see what we can get working. Going around the room, let me just show you something. going around the room, there should be a memory stick. You might have made it around already. There we are. There should be a memory stick which has the SDR drivers on it, and also this program, which is called SDR Sharp. This is a free piece of software developed by the community, pretty much specifically for these dongles and for other similar variants. In order to get started, there is a quick setup guide which I've linked somewhere. But if you go to the website RTL-SDR.com, you'll find the quick setup guide on there, and I can give you a hand after this. I'll come round and get everyone sorted. There's a program called Zadig, Z-A-D-I-G, and that will basically get rid of the Windows drivers and put on the custom drivers written by the people who first discovered this to be a SDR. That will allow you to use a program like this to use this as an SDR. So we'll sort that out later, but once you've got that installed, the first thing to do, I find with these, is go to 100 meg, shove it on wideband FM, and turn the volume up. Interesting. Find a normal radio station, because that will have the strongest signal. And that's the best way of really making sure that it's working properly. See if you can listen to Radio 1, Classic FM, whatever. I've got so many different audio devices. SDR Sharp, there's a few controls, but it's not too complicated when you realise you don't need to meddle with most of them. On the right here, down here, these are the ones that affect the FFT, the Sorcerer and Destroyer transform. That's the waterfall display you see there. The top right, this one's zoom, so you can zoom in and you can zoom out and see the whole lot. And then one below is contrast. So that's the contrast of the waterfall. Shove it all the way up to it, don't see anything, all the way down it, don't see anything. So somewhere in the middle where you can pick out where the signals are. Okay, below it you have range, and below that you have offset. You want offset right down the bottom, and then you can fiddle that with range so you get the most signal compared to noise sort of ratio on screen. Once you've done that, tune it to about 100 meg. See if you can find a radio station somewhere. That is Radio 1. It's probably due to the fact that my antenna is on the ground. So I'll just plug it into the club's beam.
Why not just stick it over by the way? See if you get off the lethal feeder.
Because I don't have enough cables to send it all over there. This should work. Not, depending on your music taste. Right, so now we've got a lovely strong signal. That's the difference to having a good antenna, obviously. So you now know it's working. There's a few things to know about these. the frequency it says it is isn't the frequency it is necessarily, because these aren't precisely calibrated instruments, they are TV dongles. So this is not a good frequency to calibrate on, but you can see how it says 99894. Well, I know that radio 1 is 99.5, so you go to the settings up here where it says configure, and it puts it on the other screen, thank you. And then there's here you've got frequency correction constant, ppm. So this would start on 0, and you can tweak it up or down to get the frequency to align to where you want it to be. I think on the internet it says, gives you some ideas of some sort of beacons that you can use to precisely calibrate that frequency. But it's not huge imports, and it will only be a few kilohertz off where you want it to be.
Does it remember that?
It does remember that, yes.
So you don't have to reset it again?
No, you don't. But that's specific to the software. So if you use it on someone else's computer, it's going to change it to whatever value they're using. Okay. Thank you. So, top you have your frequency. That is your audio gain. Turn your computer volume all the way up before you turn that all the way up, because turning that up really messes with the audio, really distorts the audio. So you're better off with full volume on your computer than you are with, well, full volume on there, otherwise you get very distorted audio. Moving down, you have your start and stop button settings. That selects what dongle you're using. You could also use like a fun cube. You can actually use these over TCP, over the internet. Never tried that, but that'd be an interesting one to try. So I think the idea is you can have a Raspberry Pi with an SDR dongle on your mast, potentially, and then you could have that wide into internet, and you can stream the IQ over your local network. Probably isn't very good for bandwidth and saturation, but it would be an interesting experiment to try one day, because you wouldn't get very much feeder loss. Below that you've got your modes, so you've got narrowband and wideband FM, AM, digital, CW, LSB, USB, and RAW, which is closest to RAW IQ. Not for me. Shift, I think it's just shifts the frequency up and down. How many times was that? Leave the filter alone. You can change the bandwidth either by changing that box, or you can click and drag on the edge of the sort of selector box, like this, and you can change your bandwidth. I really need to change the contrast on this so you can, there we go, see a bit more. So I need to play with these settings, but it's not quite right at the moment. So you change the bandwidth by doing that. You can change the CW shift and a few other things. You can, the correct IQ button gets rid of a sort of node at the center frequency, so leave that one checked. Audio, you can select your audio outputs regardless of what Windows wants it to be, although that wasn't working very well earlier. Very useful, because with SDRs you often have to make use of so-called virtual audio cables, where you pipe the audio from this piece of software into another piece of software that might decode something, for example. Below that, you've got, it gets more and more useless the further you move down, unless you're trying to do something very particular. So you can calibrate the FFT display, but if you touch any of that, you'll probably just ruin the way it's set up from personal experience. It's got a frequency manager on it, so you can sort of tag certain frequencies. You can have it scan between those frequencies. You can have it scan a range of frequencies. So I think I've got an air traffic control group on there that I can scan between. Got like a digital noise blank on it that works alright. It's got a different digital noise blank on it that works alright. This is great. This is what allows you to record the baseband, as it's called, which is the entire IQ spectrum, and you can also record standard audio. That's extremely useful for if anything. So, for example, I was playing with Hello, Fun Cube.
Can I just put in?
Yes.
We've got satellite here at the top at the moment.
What time?
Tune the SDR to the frequency on that sheet. The frequency.
What time is it going over now?
Right now. It's
Now.
ahead.
Okay. Right. Ahead of time.
It's ahead of time.
How did that happen? Right. So Fun Cube, little satellite in space. I think it's 145950. And what we have to do is change the audio output on this to cable inputs, that's the virtual audio cable, and then open up this, which is the FunCube dashboard, it's a piece of software download, change that to cable output, put this on real time, and that may or may not work, you know, we'll have to see. Thanks, John. So this should search around for the FunCube signal, and then if it picks it up, it will decode the telemetry of the FunCube and also any messages it has on it. Because it can have up to 9 messages stored on it. Nothing at the moment, but FunCube can be a bit particular. Do you know what the elevation of the pass is?
Is that on that sheet there?
Possibly.
Up there.
Yes.
There was a red sheet as well that's on there.
I also have no idea if the setup I'm using even works. But let's see. We should be able to spot it on the SDR display. Oh, this needs to be on LSP? I don't remember. Funky. Right. So I'm just playing around with the parameters on SDR Sharp to see if I can find this signal, which you can't hear unfortunately because the way I'm piping the audio, so you can't hear the audio. And then I'll just jump onto Google. FunCube 1 frequency. And the answer is 935, which is pretty close to where it was. It's sort of an intermittent sort of chirping sound on the cube. Do you know what mode it'll be, John? Do you know what mode it'll be? Upside down. I can't see anything on the...
BPSK.
Yeah, but I can't see anything on the actual SDR.
Nothing.
But-
Yeah, upper sideband.
Yeah, it's on upper sideband. It's on 935, which Google says is the right frequency. And I'll just like
This sideband modulation to PSK.
yes, yeah, it's BPSK on upper sideband. We can listen to it, but I don't think we're getting a signal off it at all. Let's shove it back onto speaker. Good attempt. Fun. It's over Greenland, John. It's gone. It's gone. Right. Yeah. FunCube is a good one to pick up. I picked it up last week, but I did it using somebody's arrow antenna. So it's a expensive satellite Yagi, 2 meters and 77s handheld. and the pass was an 80-degree elevation pass. I got it from about there all the way to over there. So you should be able to get it on a collinear, and I don't know how well it would work on a Yagi pointing horizontally because it might just get lost. So you can pick up FunCube and you can decode it, and what I was doing there is using a piece of software that's free called Virtual Audio Cable to set to the audio output on SDR Sharp and the audio input on FunCube telemetry, which is sort of a custom piece of software made by FunCube, and when you get a connection it gets all the telemetry and the messages, which is it's interesting really to see. Be something I'd like to leave running one day. So yeah, that's a potential use. Where did we get to before that? We were talking about, we're going through the settings. Oh yeah, so we're talking about recordings, baseband, things like that. Below here is another frequency manager. So these things on the left, these are basically modules, and you can get them from the internet. So I think one of these frequency managers I actually added in to the program because I wanted something that would scan between groups. You can find them online on the RTLSDR website to do all sorts of things. So it's really expandable piece of software, and it's not the only software you need to use. You can use this with HDSDR, HPSDR. There's lots and lots of different bits of software you can use. You can run it on Linux, you can run it on Mac, you can run it remotely over the internet. Okay, so what else have I got in my folder? SDR. Right, okay. So if we close down SDR Sharp, in the folder on the memory stick is also a piece of software called ADSB Sharp. ADSB stands for something detection, surveillance, broadcast, something. Aeronautical detection, something broadcast. Basically, planes have little radars on them, so we can track where they are. They're not encrypted, and you can pick them up really easily because there's line of sight to airplanes. ADSB Sharp comes with SDR Sharp. It's a very small, very simple piece of software that connects directly to the SDR, and it finds these packets. They're on, I think it's 1190 meg, 1090 meg. So it's picking up from there, and what it does is it basically hosts on your own computer a little server under that port number, which you can then connect to, and you can see all the packets. So frames per second, that's basically how many packets it's picking up, I believe. And then you can use other pieces of software such as Virtual Radar. I'm loading it now, which I always forget needs to run in admin mode, otherwise it complains. Try again. Virtual Radar, another free piece of software. See the recurring theme here, which picks up the decoded ADSB packets from ADSB Sharp, finds out where the planes are, and plots them on a map, which looks very nice. Another great thing to leave running during events and things like that. It's very, very visual. Right, so there we are. And then move back. Right, so this is what you end up with. You have a map of the UK. It never works first time, because it's either 47806, 47806, format, AVR, first feed. Try again. There we go, right. So, now I've got it set up correctly. It says it's tracking one aircraft, which is a bit pathetic. Not even showing up on that.
Because if you're under the box.
Well, I'm at the box. Too many screens. There it is, yes.
Yes, it was behind the box.
Oh no.
And that's the fun side just going down.
Yeah, that's where FunCube was when John was trying to track it on the Yagi. Right, computer's a bit unhappy. Come on. Computer's really unhappy. There we go. Right. So I don't know why we're only getting one. I'd normally expect to see about 40. I've got 2 now. But basically what this is doing is, that is, I can't read it. Maybe it's not telling me. It's not telling me. Normally it would identify the make, model of the aircraft. You have your GPS coordinates, your heading. Normally, sometimes you have where it's coming from, where it's going to, its altitude, sport code, vertical speed it works out, and speed I think it works out as well. And it plots it all on a map, and you can watch the planes fly around. This is exactly the same technology that Flight Radar 24 uses, and Flight Radar 24 is supported by people around the world having systems similar to this set up tracking airplanes. It's basically a crowdsourced mass airplane tracking system. So they're not tapping into air traffic control.
It's crashed.
Oh, it's gone. They're not tapping into air traffic control. They're just receiving these locations of planes from people around the country and around the world.
So it's like the app you can get through iPad.
Yeah, exactly.
Well,
I think we're doing it directly via the radio, which I think is a bit more interesting. Maybe not much more interesting, but we would normally get more planes than this. It's probably because we're running off a directional antenna pointed towards the horizon. Interesting to see if my 2-meter J-pole. Probably not. I'll plug it in anyway.
If you run it along the desk, see if it picks up.
Okay. Yeah, that's right there. Thank you.
See if it picks up off John's.
One here.
That's the limit of your cable, Sam. I'm only getting 3 tracked anyway. Yeah, it's not an ideal situation, but if you're outside, where you've got line of sight, all you need is this. That's all you need, and you should get a really nice. You can get planes from Ireland, planes from Europe, decent, very good range on it. So I think it's a fun thing to try. Tracking ships is almost exactly the same, different protocol, different piece of software. I won't bother showing you that. What else have we got? Virtual radar. Virtual radar. I need to refer back to my PowerPoint now.
Is this what you use for the balloons?
Yeah. So when I did balloon tracking at school, we basically school just bought loads of these. You can, if you go onto the RTL website, there is an updated version of this that's been custom redesigned in a metal case with a better quality oscillator in it and an SMA connector, most importantly. But it's about, I think it's like 25 quid, and I wouldn't bother. I mean, you can take this out of its thing and you can put it in a metal box, and then you could ground the metal box, and you can either desolder the MCX connector or you can get an adapter, and you've effectively done the same thing. This is never going to be a very precise or very well filtered piece of equipment because it just isn't designed to be. Along the same lines, I bought this from eBay for £25. This, if you take it apart, I'm not joking, it is literally just one of these circuit boards in a metal box with a pigtail that goes to an SMA connector. This does have an up converter on it though. So the up converter allows you to take it down to about 100 kilohertz, which is, I've actually barely tried that, but that removes the sort of lower limitation from these dongles, allows you to listen to HF bands. I've just been too lazy to ever really try, but I will give that a go. You've got to do something weird with the SDR Sharp software to get it to figure out what's going on. You can't just tune to lower frequency, you've got to put an offset on for a certain amount. But yeah, I mean, that having the up converter on is probably worth spending more money on, but I don't see any reason why you should spend 20 quid to have that in a metal box, just because that's better filtering or a slightly better oscillator. If you want something really good, you'd guess an SDR plane or something that's fundamentally a better piece of kit. But these serve a purpose. They're very cheap, and cheap is always good because it means lots of people can have access to them. And this is where I started. Before I knew that, I'm not making some. Before I didn't know amateur radio existed at all. I don't know how long this was, 5 years ago, maybe a bit more. Didn't know it existed. I bought one of these, and I was listening. Well, I must have known about the club afterwards, but I ended up listening to the club net on this with my laptop, sort of holding an antenna out the window because the signal was awful. But no, this is what got me into amateur radio because it was cheap. I had nothing money, but I could do lots of stuff with it. So for me, it's quite pivotal. Just flick down my list. I'll show a demo of it running on my phone later. That's about it, I think. So that's probably the PowerPoint and demonstration part of the evening over. Now we'll just see if we can get all of your laptops working, and we'll have a bit of a play, a bit of a mess around. Thank you.
Thank you.